Hello everyone, thank you for coming back to my channel. In the previous videos we have talked about the introduction of object-oriented analysis and design and also object-oriented analysis. In this video we'll talk more about the GRAPS pattern, one of the most fundamental collection of principles or patterns. It is a beginner level topic, so the only requirement that you need to have is a bit of knowledge in a language with an OP feature like Java or C#, but you don't need to be an expert in it. What is GRAPS? It stands for General Responsibility Assignments Over Pattern. It's a collection of patterns that describe the fundamental principle of object design and the assignment of responsibility expressed as pattern. It's so fundamental that you probably will think that we don't need to be told about it, or you already use it all the time without noticing it, but we still need to be able to explain everything systematically. We still need to be able to describe everything, describe every decision that we make, so we need to understand them. GRAPS contain 9 principles or patterns: creation, informational expert, high cohesive, low coupling, pure fabrication, polymorphism, control, indirection, and protect variation. And we'll talk the first 5 in this video, and we'll talk the rest in the next videos. Before we begin, there are some notes about GRAPS pattern. First of all, some people argue whether they are principle or pattern because they are so fundamental. Obviously, they are pattern, but some people think they are principles because they are so fundamental, and they may overlap each other. They may look similar. They may touch the same subject, but they actually focus on different area, and they have different impacts. They have different points of view. They have different contexts. Sometimes there are trade-offs, so we need to pick the best decision, the one that benefits us the most. And sometimes we may choose not to use them at all. This is a guidance and not rules. The first pattern that we will discuss is informational expert. Informational expert is a general principle of assigning object. Assign a responsibility to the information expert, the class that has the information necessary to fulfill the responsibility. Now let's say we have a set timer function. So where should we put it? And of course, we put it in the alarm class. We don't need to be taught about it. Even beginners will pick it. Naturally, we have instinct, but we still need to be able to describe every decision that we make. So we still need to understand this pattern. Yeah. We put it in the alarm class not because of just intuition, but it's because of a particular pattern, particular provable pattern, informational expert, and also by having all the information, we don't add more complicated logic because it's the closest class that has everything to fulfill the responsibility. The next pattern that we will discuss is the creator pattern. Creator pattern is a general principle of assigning a creating responsibility. Let's say that we have a class called tree, and it has some leaves, objects of class leaf. So tree is responsible for the creation of its leaves, the objects of class leaf. Here are some guidance when to use this pattern. B should create A object if B aggregate A object, or if B contain A object, B record instance of A objects, B closely uses A objects, or B has the initializing data that will be passed to A when it is created. Thus, B is an expert with respect to creating A. The next pattern that we will discuss is low coupling. Low coupling pattern minimizes impact. We have two pictures in here, and we can clearly see the first picture has less coupling. So prefer it compared to the second design where it has more coupling. The reason is if there is a change on the floor public interface, the first design has less impact, so there will be less maintenance. Another way to achieve low coupling is to code the interface or abstract class. The first one couple a person class to a car class, and the second one couples it to a more concept implementation. I always prefer the more generic one, because it promotes low coupling and it's more flexible. We can swap the implementation to any car implementation, and by having the car as the dependency, it offers us more variation without changing everything in person, like we want to change the implementation to sedan or truck or something like that. In that case, the person class doesn't need to change. Here are the advantages of low coupling. Change is minimized, of course, easier to comprehend structure because there are a few coupling and few connection, and it's easier to reuse because when a class has a lot of dependency, we have to bring all dependency when we want to use that class. Next pattern that we'll discuss is high cohesive. High cohesive ensures that a class doesn't contain too much responsibility. Let's say that the self-service contains the business logic of the cell, and the first design delegates the data access to a class called sales repository, and the second one makes self-service does everything. And I always prefer the first design because here are the advantages and disadvantages. The disadvantage of low cohesive classes: hard to comprehend, it's hard to reuse because a particular usable code is buried in a particular class, hard to maintain, and delicate, constantly affected by change because there are a lot of duplication in low cohesive system. Our classes does everything without delegating, so there are a lot of duplication, and one change can affect everything, can have a lot of impact. And the advantage are clarity, maintenance are simplified, low coupling is supported, and imagine if you put everything in one file, everything can be coupled to each other, so it's very frail. But if you partition it into multiple classes, we can design the coupling, we can minimize the coupling, and it also supports reusability because a high cohesive class can be used for a very specific purpose. Next one is pure fabrication. We have talked about the domain object previously. They are representation of real life object, and they inspire the domain layer of software classes. You can see in the bottom there are classes which are inspired by the object from the domain object. The bottom classes are domain layer objects, and sometimes, or actually all the time, we need classes that don't exist in the real life. the top one. Sales repo, text utility, text fronter, they don't exist in real life, but we still need them. Yeah, it's like we make something up. Yeah. Not all classes are based on the domain objects. So here's the end of this video. In the next video, we'll talk more about the rest of the grabs pattern. Thank you.